This is section 2D, part 2, and we'll now look at a rule for quotients. If we've got two functions that are being divided, in order to take the derivative, we have gf prime minus fg prime over g squared. Here's the full function notation, or just to make it look a little simpler, we can leave off all the function notation and just write it this way. Like the product rule, this is one I'd like you to get to know. I don't give you this formula on your tests. You should be familiar with it. People sometimes think of this as the top and bottom functions. So it's bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. All right. Once again, I'm not really proving that to you, so I'm going to do one problem two different ways. One way that we already know, and then again with the quotient rule, just to show that it really does seem to work and we really get the same answer. So here's a problem that you could have done back in the last section. In order to take the derivative of this quotient, we would have said, let's divide this out first. And we would have said that's 2x to the second minus 5x to the first. And so f prime is just going to be 4x to the first minus, just the slope there is 5. So if we do the division first, it's a pretty simple derivative. Let's just show that we get the same answer using this new quotient rule. If I want to use the quotient rule, I'm going to define the f as the top function and the g as the bottom. And again, sometimes when my function's already got a name like f or g, I just use capitals just to make sure I don't confuse myself later. So let's think f and g. F is the numerator, and g is the denominator. That means that f prime would be 8x cubed minus 15x squared, and g prime would be 2x. So the derivative of my original function, little f prime of x, is my quotient rule, gf prime minus fg prime over g squared. And oops, you know what? Sorry about that. I don't know why. It bothers me when I mix these. I was using capitals. Let's make these positive, these uppercase capital G's. So G is 2, or is x squared rather? And f prime, 8x cubed minus 15x squared. I then subtract f, 2x to the fourth minus 5x cubed, times g prime, which is 2x. And then in the denominator I have g squared, so that would be x squared squared. All right, some algebra to do. I'm going to distribute the x squared. So 8x to the fifth minus 15x to the fourth. And then I'm going to distribute both the negative and the 2x. So negative 4x to the fifth. And negative times negative would be positive 10x to the fourth. Over x to the fourth. Combining my like terms on top, I'm going to get 4x to the fifth and a negative 5x to the fourth. And then just doing that division gives me 4x to the first minus just a 5. And lo and behold, we do get the same answer that we got a whole lot more easily when we did the problem just by dividing first. So, a couple points here. First of all, the quotient rule certainly seems to work. We did get the right answer. But secondly, it takes some algebra, it takes some work, right? So if you can divide first, it's usually going to be much more efficient to just do the division first and then take the derivative. If that's not possible, then you've got the quotient rule here to help. So on the next page, we've got a few problems where we really don't have a choice. In number 2, although I guess I could do long division, that's not something I probably want to really get into. It makes kind of a mess. So it's not as simple as just dividing by one term. I'm really kind of more stuck with the quotient rule here. So f is the top and g is the bottom. F is x squared plus 2, and g is x cubed minus 4x. That means that f prime is 2x, and g prime is 3x squared minus 4. So let's see, going to do my quotient rule. Y prime is going to be gf prime minus fg prime over g squared. So let's see here, g times f prime, which is just 2x, minus f times the g prime over g squared. Now again, I'm going to ask for basic simplification. The denominator is really no problem. The denominator is in a fully factored form, so I'm fine with just leaving that. But the numerator is a little weird, right? We got multiplication, subtraction, multiplication. Let's go ahead and multiply that out and see if we can simplify that numerator a bit. So distributing the 2x to the 4th, minus 8x squared. And let's see if we can wrap our brains around a FOIL process and distributing a negative at the same time. We'd have 6x to the 4th, which will be negative. And then I have a 6x squared minus 4x squared. So that'd be 2x squared, but negative. And then a negative 8, but with that negative it makes it a plus 8. All right, now it's just tidying up, right? We have a negative 4x to the 4th, a negative 10x squared plus 8. And again, the denominator, I'm not going to bother multiplying that out. You can if you want to, but it's already in a nice factored form, so I'm just going to leave it that way. All right, let's try number 2. Once again, I can see that I can't simplify this. I can't divide first. So I am going to go ahead and use my quotient rule. It looks like here we would have f is the numerator again, and g is the denominator. So f will be 2e to the t minus 5, and g will be 3 sine t. That means that f prime will be 2e to the t. The derivative of that constant term 5 is 0. And g prime will be 3 cosine t. So let's see. We haven't used Leibniz notation for a little while. This would be dy dt. And again, it's gf prime minus fg prime over g squared. So plugging everything in, 3 sine t times 2e to the t for the gf prime. Subtract the f times the g prime over g squared. Doing a little bit of simplification, I'll multiply by coefficient 6, and I'm going to bring that e to the t in the front, times sine t. And sort of the same thing here, I'd have a negative 6 e to the t cosine t. And then it was like a positive 15 cosine t. And since that's just a product and not a sum, it's so easy to multiply out, I think I'll go ahead and do it. 3 squared would be 9, and then I'd have sine squared t. So there's my derivative. All right, one more. I can clearly see the quotient again, and not much I can do, nothing I can actually do to simplify it, so I'm kind of stuck with it. So f is my numerator and g is my denominator. F prime is no problem. The derivative of 5e to the x is still 5e to the x. But take a look at that g. What are you seeing there? G's a product, right? So in order to do g prime, I'm actually going to have to do a product rule. I'm going to call this capital F and that capital G. So capital F prime is 3x squared, and capital G prime is the opposite of sine x. Little g prime then is going to be fg prime plus gf prime. So let's see, fg prime. fg prime, I'm going to drag that negative out in front, so negative x cubed sine x plus gf prime 3x squared cosine x. All right, let's now put all of this back together in a quotient rule for the original problem. So h prime of x is little g f prime minus fg prime over g squared, which will be little g x cubed cosine x f prime 5e to the x, subtract f 5e to the x times g prime, which is all of this, over g squared x cubed cosine x squared. Phew, all right, it's all there. Just a matter of collecting things the way we want them. So I have, I'd like to write that as 5x cubed e to the x cosine x. Again, typically numerical, powers of x, exponential, and then trig. These I'm going to multiply and make that a plus 5 x cubed e to the x sine x. And then finally here I'm going to get a negative 15 x squared e to the x cosine x. In the denominator, we can go ahead and square that out. Again, when there's no adding or subtracting between the terms, right? When there is, you have to use FOIL. It's not quite as nice, but when it's just a product, you can just square both factors. So x to the 6th cosine squared x. Now that's not bad, and I probably would say it was okay even if you left it just like that. But I am actually going to notice that there is a little bit of simplification I could do here. Do you notice that x squared divides into all of those, and I could actually divide an x squared out of the denominator as well? So I'm actually just going to take one more moment and say, what if we divided by x squared over x squared? And the bottom would just be x to the 4th cosine x. So there's a fully multiplied out and simplified version of the answer. Again, you could factor that numerator if you wanted to, but you don't have to. All right, that brings us to the end of topic D.